Our speaker this evening has previously held roles as engineering lead at Oracle, at Docker, and was a technical director for MongoDB. Please welcome the VP of Product for Aerospike, Alvin Richards.
All right, so I've got to try and project my voice. Can you hear me at the back?
Not really.
Not really, okay. All right, so tough, come and sit down here. All right, my mum, who I love dearly, she is going to be 83 this year. And she has absolutely no idea what I do for a living. And so the only way I can possibly demonstrate it is if you all wave and say hello, I'll take a picture. All right, can we do that?
Yes.
All right, let's go. All right, 1, 2, 3, go. All right, you guys are all awesome. Right, who of you use Docker or containers in general? A couple of you. Who uses databases? Oh, that's better. Who uses a NoSQL database? Okay. Who uses Aerospike? See, there's always one. I love you dearly, thank you, sir. Okay, so what we're going to talk about is containers and databases, because that seems a fun thing to do. And then we'll talk, I'll try and do some live coding, especially after PBR. So this could be highly amusing. It's a live demo, so the chances of it working first time are small. I type really badly, so there's bound to be lots of typing mistakes, and I'm sure we can give prizes for you spotting my typing mistakes. All right, so let's go. Are you ready?
Yeah.
Yes. Are you sure?
Yeah.
All right, I'm going to give you the conclusion first because it's always fun to start at the end. So containers and databases, all the developers are super happy about that. Ephemeral containers and databases give the DevOps people headaches would be nice, probably nightmares right now is probably more appropriate. So ultimately, there's 4 things you really need to think about with database and containers. You've got to think about data redundancy, availability, the ability for these clusters to self-form, and the ability for your application to find these clusters when they are constantly moving around and reforming. So those are the 4 things that you'll need to try and evaluate, irregardless of what technology you're using. But I'll try and map this back to how Aerospike fits into this. Okay, I'm a lover of old black and white movies. It's not because I really am that old, but it's like I grew up in England and there was 2 TV channels, and they would play Laurel and Hardy reruns endlessly. It's another fine mess we got into. All right, I've got to speak louder than this. All right, I am not going to be able to speak at the end of this. Okay, so the fine mess we've got ourselves into is something like this, which is we've built these enormous architectures where we've got a database, and then the database didn't quite go fast enough, so we put a cache in front of it, and our applications are sitting on top of a cache. And then somebody had this great idea about building a data lake with Hadoop on the side, and then building some more applications on that. And then you end up with this huge amount of complexity because you've got message buses pumping things left, right, and center, and your chance of actually holding all of these parts in your mind is very small. I was talking to the former SVP of engineering at Google the other day, and he claimed, and I believe him because he's a smart guy, that there were only 3 people inside Google who could explain how a Google search would work from the point that you type something on a web browser all the way back to the results. Literally 3 people understood how all of the systems interwork together and how that one transaction would work. And so we built a whole bunch of complexity. Who likes complexity? This guy likes complexity. I love you dearly.
It's what we get paid to solve.
Okay, how do we deploy things? Well, this has got a bit complicated because I want to get from dev into test and stage and production, and then there's all these dependencies because I'm using this version of Linux, and I'm using some Python packages and blah, 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 blah. And some teams have got Salt, and others got Ansible and Chef and Puppet. And I've built, as complex as my application is, my deployment architecture is just as complex. And oh my God, trying to debug this is pretty tricky too. And then you've got your right? So you've got this lovely shiny new box that you've provisioned in Amazon, or you've actually paid real money for in a data center. And in the traditional world, you've got a database that's sitting on top of a file system, on top of a page cache, on top of block devices, and you've got all of this myriad of inefficiencies between that stack. Really, you want your database talking to RAM, and then parallelize all of your IOPS without any of the garbage in between. So we built something that's very complex, very inefficient, that nobody understands. Awesome job, everybody. All right, so what are some of the challenges we want to meet? Well, containers, as we'll talk about in a minute, kind of, if you think about them as encapsulating all your dependencies and giving you isolation at runtime. That's a simple kind of, super bullet. The database, of course, you all use databases. What do you use them for?
Data.
For data for persistence, essentially. Therefore, your system of record. It could be for your system of engagement, but generally your system of record because you don't want to lose that data. Losing data is fun when you're trying to talk to the IRS, but they will generally fine you, or the SEC or whatever. Okay, let us talk about containers. Can you still hear me?
Yeah.
All right. Your job at the back is, if you can't hear me, shout, because at some point, I might start decaying. Okay, containers. So some of you know containers. Who are using containers in production? Any of you? All right, 1, 2. Okay, that's awesome. Typically, I would see about a third of the room put their hand up. So something's happening different in New York than it is in London and in the West Coast. So that's kind of interesting. All right, the whole idea of containers is to simplify building, shipping, and running your executable, whatever your executable is. There's a whole bunch of layers in that stack, which we'll talk about in a little bit, but that's the mission statement. So what do containers give me? I think of it quite simply as an encapsulation of dependencies. Right? If you think about your application, what is it? It's the code that you've written, then it's a bunch of packages that's dependent on, or libraries, then it's some version or distribution of the operating system, and then probably some level of patches that your DevOps team or your security team want to have enabled on that. Once you've got all those dependencies, what you want to ensure is that the thing that's running inside your container is isolated from everything else, right? It's one of the reasons people liked virtualization, because it gave I could take a big machine, carve it up into lots of smaller machines, and then I've got some level of isolation between them. So think of containers as faster, lighter weight virtualization. It's not strictly true, but it's true enough to get your head around as we talk about these next couple of things. Questions so far? Everybody still with me? Okay. I obviously need another PDR. Okay, so how do I encapsulate those dependencies? So this is an example of a Docker file, and it's vaguely human readable. If you like the bells or symphonies or something. All right, so the first line here is I'm going to say I'm going to base this image on Python, and I'm going to pick a particular version of Python, in this case 2.7. That's awesome. Then what I'm going to do is add everything in my current directory to something called /code. So it's going to take everything that just happens to be sitting in my current directory, package it all up, and shove it into this virtual directory. Then I'm going to run a couple of commands. I'm going to do an apt-get update, and then I'm going to install some Linux packages. That's always fun, because there's always a package that's missing. And then I'm going to run pip install. All that is in Python. I can now specify a series of Python libraries I want. Java's got the same thing through Maven, Node through whatever the Node thing is. And then I'm going to expose the port, and then I'm going to run a command, which is Python, then app.py, right? So it's kind of fairly easy to look at one of these Docker files and go, okay, I kind of see what it wants. And then this is used to actually, each one of these instructions is interpreted, and then an image is built with all of that content in, right? If you think about an image, or you think about a process running, what does a process running in Linux look like?
Process?
It's a process, but what about what's on the file system? I could represent that process as just a ton of files, right? Because there's stuff in /proc, there's stuff in the operating system, blah, 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 blah. So what a container is a huge artifact of all of those files, all munched together. Okay, so as it turns out, people seem to like containers, and they don't seem to like VMware very much. Anybody works at VMware? All right. They don't seem to like VMware very much because it's one of these big traditional enterprise vendors that charges you lots for everything. And people like open source, and they want an open container standard. So the OCI was developed in order that all of this big long list of every logo you've ever seen in enterprise software can contribute and mangle the standard together, but keep it open and interoperable so you can choose to buy your containers from whoever you want to buy them from. And I'm sure that list is much longer these days. So it's an open standard, it's not meant to be vendor specific. I'll talk about Docker specifically. This is a kind of complex chart, so let me try and start at the top left. So the top left is a container. The container is essentially the definition of the process you want to run. In the middle, you've got the whale, called Molly, if you've ever wanted to know. The whale is called Molly, and Docker Inc. Have actually sponsored a whale that's swimming around the Pacific Ocean. You can track it real time, so you can actually see where Molly the whale really is. But the analogy here is that the whale has got all these containers on its back. Right, so essentially, the Docker engine is the runtime for all of these containers. Now my application is made up of more than one container. If you like microservices, anybody building any microservices? Several of you. Okay, so you'll probably run each microservice in a container. Now my application is made up of hundreds of these microservices. So let's say each one of those microservices in a container. How do I orchestrate that? That's Docker Compose, the octopus in the corner, which is there to orchestrate these many containers that are all interrelated. And then anybody wants to run everything on one machine? I'm guessing probably not. Okay, so I now, he wants to run in dev, but in production you may want maybe 2 machines in case one crashes. Let's say, assuming you want 2 machines, Docker Swarm is the way to actually cluster these machines together, so you've got one virtual deployment that you can push all these containers to, and then Docker Machine at the bottom is the way that you provision new machines. Okay, so there are lots of acronyms and lots of tools, and the first time you get into the Docker ecosystem, your head may explode because you go, do I want an image, do I want a machine, do I want a swarm, how does Compose a machine fit into this? Hopefully that simplifies the picture. Okay, any questions on this before we go on?
Yeah, can you distinguish the machine from the swarm?
So machine is the process. So the question was, what is machine? Machine is the tool, I should say, that creates essentially a runtime environment.
So it runs the Docker file shows?
No, it creates a Docker engine that could run the Docker, that could run the container. So how do I get my first runtime environment? You run Docker machine to go and create essentially a virtual machine if it's on a desktop, or a machine that's running on EC2 or Azure, or you pick your favorite cloud vendor. Once I've got several engines running, I can then use Swarm to make them appear as one big machine. Make sense? All right. Don't worry if this confuses you, because the first time I saw this, I went, strange acronym with lots of swear words in it. Yes?
So a Docker, would I carry the whole JVM from one machine to the other in a container?
So the question is, if I'm running Java, do I run the whole JVM inside the Docker container? Absolutely.
Oh.
It's process encapsulation. So it's encapsulating that whole process. Whether it's a JVM or it's a Python runtime or it's Node, it's the whole thing.
How is it different from virtual or Vagrant or something like that?
So the question was, how is this different from virtual machines and Vagrant? I should have drawn a picture to describe that. The big difference between virtual machines and containers is this. virtual machines, essentially you've got layers to virtualize the hardware, memory, the network, etc., CPU, etc. All essentially a container is process isolation, right? So this is using some of the Linux native C groups that essentially put a box around the process running, right? So you've removed all of that virtualization of the hardware, and so this is typically why people would see, 8 to 10 to 12x better density running containers rather than virtual machines. So you don't have to keep on virtualizing the same CPU. It's done with process isolation rather than virtualization.
What is a density?
The question is,
What's the density metric that you just referred to?
So the question was, what's the density metric? This is how many VMs or containers you can run on the same box. So I work with a customer, and they got from their Cisco UCS blade about 12x better density. Right? That's pretty interesting. So that you get to play different games with the resources. I think there's a question behind.
Dependency is duplicated. So if you have JVM in one container, two container.
All right, so the question is, if I've got JVMs in multiple containers, do I get duplication? So at the bottom of Docker, although I guess this isn't Docker talk, at the bottom of Docker is essentially a union file system, right? So what this means is that if you've got two images, in my previous example, both based on Python 2.7, you only got Python 2.7 stored once. And so if you think of each one of those commands in that Docker file as a layer, and what you're doing is that you're building the differences on top of each other, which means that you get essentially on disk savings because you end up sharing all of those root images. So you only have to save, store the deltas in effect.
That's the disk storage. The in-memory storage? I've got 2 copies of Python.
So the question was, what happens to in memory? So it's the same model, underlying Linux model, which is if you've got 2 processes with the same underlying binary that you're running, you're going to get the same utilization as you would do out of generic Linux. All right, one last question before we move on.
Yeah, I've been doing some research into containers, and my first question is this what we call bare metal containers that use the processor? 2, I was just reading that YouTube just released their Docker or container called LXC or LXD. Is that any different from what you're talking about?
Right, so the question is I've got a container, where does it run, or how does it run? You could run a container essentially on bare metal. You could run containers inside virtual machine. In the demos I'll do later, I'm running VMware Fusion on my Mac, and the containers are running inside that Linux VM. So equally, if I run a container on Amazon EC2, Amazon's running Zen as its virtualization, so Docker is running inside a Zen VM. So you can run it on bare metal, you can run it virtualized. Obviously on bare metal you're going to get much better density than you are virtualized, for all the reasons we talked about earlier. All right, I'm going to move on. We've got one Aerospike gentleman over here. That's awesome. I'm going to tell you, because marketing forced me to do this against my better judgment, to tell you something about Aerospike, and hopefully you'll forgive me. All right, so the bottom line is Aerospike is a key value store. Think of it as a big distributed hash table. Typically what we find is we get 10x better density than Cassandra or a MongoDB, simply because the underneath technology is that we built our own proprietary log structured file system that sits on top of SSDs, which means that you haven't got all of those layers in the operating system between you and doing an IOP. What it allows us to do is massively parallelize reads and writes to Flash in ways that ext3 and even ZFS were not really designed to do. And so this is a real customer example where they saved $250,000 per annum just with better utilization of existing hardware. How do we do this? Essentially, as I said, Aerospike is a big hash table. It's a distributed hash table, so it goes across multiple servers. We use an algorithm which is a collision-free algorithm called RIPEMD160, and essentially that takes a big hash of your record, and the first 12 bits of that determine which node the data resides on. Inbuilt into that is replication. So if you care about having more than one copy of your data, you can set the replication factor, and then the data is replicated to other nodes in that system. Our primary index is a red-black tree. Red-black tree sits in DRAM, and the rest of the data sits in SSD. So we keep, because it's a key value store, so we want the key value lookup to be fast. That's why it's a red-black, it's a parentless red-black tree, where we do the primary key lookup and then go to the SSD. Okay, inbuilt into that is a whole bunch of algorithms to do self-healing. Right, so if you lose a node in the cluster, you want the other nodes to actually take over and re-replicate that data. So if you've got a replication factor of 3, you lose a node, you'll obviously want to create an additional copy of that data elsewhere. We've got a customer in production in New York, in ad tech. They've been in production 5 years now, and they've had 5 minutes of downtime in 5 years. They've actually claimed 3 minutes of that downtime was their own fault because they got an alert through their alerting mechanism, and they went, I've never seen that before, what's that about? So it's really designed for high reliability and uptime. Okay, how do we do that? As I said, it's a proprietary log structure file system. What we're really doing is taking advantage of how Flash works. Right, on Flash, what you've got to do is you've got to write large blocks, and then you've got to read small blocks. And the reason why log structured works really well is who's heard about wear characteristics or Flash wearing out? Yeah, some people, right? So the problem with Flash is that if I keep on updating the same block again and again and again and again, the Flash device over time, basically the NAND just flakes out on you, right? So what all the NAND manufacturers did, they built algorithms in that said, if this block keeps on getting written again and again and again, I'm going to relocate it to somewhere else in the device and do a sort of pointer in direction that you won't know about. And so the write will still occur, then I can even out the wear everywhere. The problem with that is that then causes inconsistent latency, because sometimes you go to the block and you've got the right block, sometimes you've got to hop around in order to find where the block really is now. So by doing a log structure file system, it means you're doing append, 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 append. As you wrap back around, you can overwrite those blocks that are no longer that have been freed up because you have overwritten data. So this means that we get much better consistency of SSD, not just out of the box, but a month down the road, 6 months down the road, 12 months down the road. And it's a key to actually maintaining that level of performance over time. How is Aerospike used? One of my favorite use cases is in real-time fraud. Who's got a credit card? Everybody's got a credit card, right? I must be boring you because you can't put your hands up anymore. All right, so what is the problem? This is a very well-known payment processor. So when you swipe a credit card, they have something called blink time. And they say blink time is about 750 milliseconds. This is the amount of time that you standing at the terminal after swiping the card really want to wait until it says approved, right? Because being at a terminal and swiping it's taking a long time, you feel self-conscious. And then when it comes back to client, you feel like a right idiot because you've got to then find another credit card and swipe it. So the payment processor, the point you pull out another credit card and swipe it, it's lost business, right? Now, so they really want to say yes, but with all this crazy fraud stuff that's going on, they needed more and more rules to process. So currently, these guys were processing about 200 rules per credit card swipe. And they realized with all the kind of crazy fraud stuff that was going on, what they wanted to do is increase that from 200 rules they have to evaluate to 1,800 rules. And so that gives you a very kind of different kind of dimension that you start having to scale. And in order to do that, you need a database that not only can write data quickly, it needs to read data quickly, because you need to do that. In parallel. If anybody remembers what happened to Target a year ago, people started installing malware on those Target devices. So if you think about one of those payment terminals, it's got an IP address. So an IP address is pretty good, it's fine, and then at some point that IP address goes bad because somebody's put some malware in there. So you can't simply rely on your data lake and your batch processing to tell you what your algorithm should be or your models should be. Your models need to be looked up in real time, but you need to modify those models in real time as well, because when an IP address goes bad, you want to ensure that no other transactions occur there. So you've got to deal with very large volumes of read-write. This is another customer scenario. So this is Google Compute. Our friends at Google, they are literally just across the street. They often do a whole bunch of benchmarking with Aerospike, and they did a benchmark of Aerospike versus Cassandra to do mixed read-write loads on YCSB, which is one of the standard benchmarks. And so you can see you can hit 1 million writes a second with 6 times less servers. So anybody who has not only a growth problem but wants to save money, because apparently money is going out of fashion and VCs are not giving you any money anymore, this is a good way to save some money. And if you're using Redis, there's another benchmark, and you can go and look at the details of this, about how to go from 12 Redis shards down to 1 Aerospike shard. All right. Any questions about Aerospike before I go on to any other business? Okay.
How would Aerospike compare to other NoSQL DBs? You mentioned Cassandra, but what about other ones like React and MongoDB and Couchbase?
That's a great question. The question is, how does Aerospike compare to other NoSQL databases? Literally, I can stand up here for about 2-3 hours to talk all about that. I spent 5 years at MongoDB. I was employee number 12 there, so I can tell you all about that. Very quickly, if you think about families, MongoDB is a document database. React, Couch, Aerospike, Redis are key value stores. You could argue that Couch is a document store as well. It's really a key value store that stores JSON. Then you've got wide common families, which is Cassandra. Then you've got graph databases like Neo4j and the other one. So that's kind of broadly how they all split out. I'm more than happy to go into extraordinary detail if you provide another beer in my hand after we finish. Okay? All right. Aerospike and Docker. This is the crux of what we're going to talk about. So let's just move here. So we talked about four things to evaluate. Data redundancy, cluster formation, healing, and application discovery. So how does Aerospike do this? So Aerospike is a shared nothing architecture, which means all the nodes are performing the same role. You can determine programmatically or through a policy how many copies of that data should be written. So if you don't particularly love your data, you can have 1 copy, and if you lose that node, then you have to rely on your good backup, which of course you have been doing, right? Because everybody does their backups and then checks their backups that really work. But if you love your data a little bit more, perhaps you want to create 2 copies, or maybe 3 copies, or 5 copies. You can specify that via a policy. Now, once I've got 1 node, so I guess people are running Oracle and MySQL and Postgres here. Yeah, okay. So 1 node's great. It's a bit like children. You know, I loved my first child, and then I loved my second child when I had 2 things running. But loving 1,000 children may be certainly beyond my capability. And so what you need is, as you're adding new nodes, you want these nodes to self-discover each other and form clusters themselves. So inbuilt into Aerospike is the ability to use multicast and mesh networks. And so they'll see the broadcast on the network, and they go, oh, you're one of us, why don't you come and join and play the party? And that node will join, and then data will get redistributed around that cluster. As obviously a node disappears, the rest of the cluster will go, oh my god, that node went away, how shocking is that? And then they'll again remove the data around in order to make sure the cluster's balanced. And finally, you've got your application. So if you've hardwired a host name or maybe an IP address into your application and that host disappears, then you're going to have to restart your application, right? So the application needs to be able to, or the client that's talking to the database on behalf of the application needs to actually understand what the topology is as the topology is changing, and therefore ensure that the client remains connected to the cluster as a whole. And so you need to have that built in. So Aerospike's got that built in. We've got most of the popular languages: Java, C#, C, C++, Python, Node, PHP, Ruby on a good day. Have I missed anybody out? Anybody want another language? Erlang, yes, we have an Erlang driver. It needs some love. So, we're willing to take, donations for the Erlang love. Anything else? Oh, Go, we've got a Go driver too.
SQL?
SQL, yes, we have a JDBC connector for you crazy SQL people. I was a crazy SQL person. The first version of Oracle I used was Oracle 4. It had an uptime of maybe a minute, 2 minutes on a good day. Oracle 5 was better. All right. Who wants to see a demo? Who wants to see some code? You're saying, thank God I don't have to listen to that English person speak anymore. Good job, I'm really an American. Okay, so what we're going to try and do is we're going to build an application, we're going to do some work in dev, and then we're going to take the same application, and those crazy ops people want to ensure that you can load balance it, and they want to inject some dependencies and blah, blah, blah. So we'll try and show the whole life cycle going from dev to production. And scaling the web tier, scaling the database tier. Okay, so we're going to start here. We're going to use a Python and Flask container and Aerospike, and then we're going to end up over here with HAProxy in front of our farm of application servers behind a cluster of Aerospike. All right, and we're not going to have to change any code to do this. Who thinks that might be awesome? At least one. All right, the rest of you can go. You're all haters, right? It's all about you. Okay, so let's go build an application. Right, everybody at the back can vaguely see that? They're not denying, so okay. So here's a piece of Python. Who is familiar with Python? It's just code. It's like code like any other language. I'll point out some of the key things here. Is like, here's how I establish a connection. I just do a connect. And then further down in my web application, I want to increment some counters, because that might be nice. And then I want to, somewhere over here, I do a query. Right, so this application is inserting some data, it's updating some counters, and it's doing a query. Right, so it's not a simple one operation, it's doing multiple operations. It's still pretty trivial. So let's come over here. So I now want to, I use Docker Compose, right? So I'm going to now say build, because building my image might be fun. There it is, it's building away. And you go, how is it doing that magic? So it's going, if we go to our Docker file, this is the Docker file you saw earlier, and what we're saying is here is we're going to use Python, we're going to update our Linux distro, we're going to install some additional Linux packages, we are going to run pip installs, so we're going to run some add some Python dependencies. But bear in mind, this could be anything in your particular language, right? You could be pulling you could be pulling new packages for Java or whatever. And then finally at the end, it says, look, we're going to expose a specific port, and then we're going to run Python with app.py. And app.py is this file that we were just looking at. Okay, so this is all built in here. Isn't that awesome? It's giving me some warning. Yes, I'd like to upgrade, but no. Right, so we can now do Docker Compose. Thank you. All right. So we've now set Docker Compose up. Right, Docker Compose is the orchestration piece. Oh, I should bring this up a bit so perhaps you can see it at the back. Is that better? All right. So we're now saying to Docker Compose, what I want you to do is take the definition of the application and now execute it. So let's go and have a look at that definition first. So here's our YAML file. What I've done is describe two services, web application and the Aerospike server, or the Aerospike service. And so I'm adding a few commands here, which is build. So as we saw a second ago, I needed to build that image, so we can specify how to do that. I'm saying I'm also going to map some ports. I know that on the inside, that container is exposing port 5000. I could map that to a different port on the outside. I'm keeping that the same. This links command says I'm linking to this container of Aerospike. So this is going to allow these two containers to talk to each other over TCP/IP. Otherwise, you know, a container is a process boundary. If you don't open up the ports, then they can't talk to each other. I'm going to specify a host name and an environment variable. Don't worry about that too much. So that's our application. The second part is our database, Aerospike here, and I'm going to use a specific image. So Docker provides a place for you to store images. You can get official images. So a vendor like Aerospike, you can put official images up, and you can use those official images. So there's official images for Python, for various forms of Debian, So I'm going to say from the Aerospike repository, I'm going to use Aerospike server, and I use the tag of latest. So this is just going to get me the current latest version. And I can also mount some volumes, and we'll talk about volumes at the end, but all I'm allowing this to do is allow the container to talk to storage outside of the container. And we'll see why that's important in a minute. So that is the definition of my two services and how they link together. So if I now do Docker Compose up, you can see those two services starting, and you can see a whole bunch of log messages. Who wants to see the application running? Yes, I spent literally hundreds of man-years on this awesome application, which you can all love, which allows you to choose Coke, Pepsi, or tap water to vote. So it's simply recording your preference. I did have this as candidates in the upcoming election, and that was deemed by our marketing team to be slightly controversial. So I went safe this time. Okay, so we're voting, and obviously those votes have been recorded in the Aerospike database, and we can go and have a look at that in a minute. So this is awesome. I think my application is working. I'm the developer. I say push to production. Who thinks we should do that?
Yes.
Everybody thinks we should do that. Great. Okay, so let's go back over here. So we built the application. I've given my looks good to me. And we talked about these details, but the slides will be available afterwards, but you can see you can actually specify all the things you need to do, including which images to use. So our darn ops team, they've said that there may be scalability issues with this application. They're expecting enormous influx of demand for people to vote for their favorite beverage. And so they're insisting that we have HAProxy, which is just a load balancer, in front of our web tier, so that we can simply add more application servers on demand as we need. So in the next demo, what we're going to try and do is go from 1 to n number of application servers. Okay? So, before we do that, so far on my development machine, I've been running on a single machine. Do we like running on a single machine in production? No, good. All right, so how do I now have all of these containers running on all these different servers? Okay, this is where Docker networking comes in. All right, so this is a busy diagram, but the crux of it is anybody who's set up these type of applications in production has almost certainly created a VLAN between their application and the databases to ensure that the IP traffic only goes between a certain segment on the network. In Docker networking, from 1.6 onwards, essentially creates a VXLAN. It's a virtual LAN, and then what it does is it sets all the permissions up so that only specific containers can attach to that VLAN, and therefore only those containers can talk to each other. Right? So this allows you to create any number of networks. And in this case, we've got two networks. We've got our overlay network called prod going between these 4 physical machines. And then we've got a bridge network, which is just talking to the outside.
Is the traffic encrypted?
The question is the traffic encrypted? From what I remember, it isn't encrypted. But I'm sure you can turn on TLS for that traffic. But that's a good question, don't know.
I noticed you ran Docker Compose, which I thought was for deploying swarms or multiple containers, but you were building just one instance of it.
Very good question. So I'm using Docker Compose. Dude, isn't that for like deploying to swarms? Well, the great thing about Compose is I can deploy everything to a single server. And what we'll see in a second is I can use that same Compose file to now deploy to many servers. And we'll give you a pair of, if we haven't run out of socks, I'll give you a pair of socks for that plant. Cool. Okay. Okay, so let's scale the web tier. So, over here, this is a separate environment. So I'm going to do Docker Compose up, and I'm going to say -D just to run this in the background to detach it. And as you'll see, there are 4 services created. You may go, Alvin, what's going on? So let's go and look at what we've done this time. So here is my Docker file for production. So I've defined 4 services, HAProxy, because I insist on running everything with the load balancer in front. Now you can see this specific syntax inside the Compose file where I can extend other existing Compose files. And so we'll dive into this in a second, but what I'm saying is HAProxy extends this file called HAProxy for this particular service. So think of this as your ops team defining a set of base images or base behaviors that you can simply then overlay on top. So if I go and dive into HAProxy, here's HAProxy server. All it's saying is it's using a particular image. Again, this is an Aerospike image, and it's setting up some environment variables and volumes and port mappings, and it's running a particular command just to start off HAProxy. Right, so this allows the good separation of dev from ops, so that all those things that the ops team care about, that they can inject that behavior on top of the files that the development team is specifying for how their image should be packaged. Right, so it allows you to inject that behavior. So going back to our other Compose file, here is my application. I'm actually using an image rather than building it because I don't want my ops team to rebuild the image. I want to take the image that the development team has produced. Right? I don't want the ops team to modify or monkey with that without good due course. Again, I'm using the extends as we saw earlier. If I go down further, here is my Aerospike service. Again, I'm extending a base service, and I'm going to use a published image. But instead of using the latest, I can now actually set a concrete version. Right? I want to use 7.3.4. Right? Typically, when you're deploying to ops, you don't simply want to take the latest. You're using some specific version that's been blessed by somebody with a very long job title who got their team to bless it. And you want to ensure that you're always using that particular version. One other thing that's worth noting here is that we talked about swarm, and you've got these multiple hosts. Well, just like in VMware, you may want to set affinity rules or constraints. Right, so what I'm doing here in this affinity rule is I'm defining a label. It's com.aerospike.cluster, and I'm giving it a value of pod cluster. My affinity rule says the way to read this is this container can be deployed on a host where there is no other container running with the name of pod cluster. What that is doing is ensuring that only one Aerospike container can run per host. Right? Because if I put all of my Aerospike containers on one host and I lose that host, you've gone and lost your cluster. You want to ensure that those containers are spread across your whole farm. And so in Docker, you can put affinity rules. It could be on container, how close containers can be. It could be specifying a type of processor or SSD that that host has got available. So you can build up fairly sophisticated rules for the ops team. All right. So, if I go to my prod page, and I do a refresh, here is my application. Okay, it's the same old application that we've seen. But as I've got this kind of diagram down here, which the people at the bottom that might not be able to see. I've got a pictorial representation of our cluster at the moment. As you can see, we've got a single database and a single application server. Who wants to scale the application server?
Sure.
All right, let's do it. This is how you scale. Docker compose, scale, and you put, oops. Then the name of the service, which is where, how many more of these containers you want to run. That's 5. So it's now ensuring that there are 5 containers running. And as you can see on my diagram down here, we can actually see 5 of the green boxes running. Is my application still running? Let's try it. Right, so my application is now behind HAProxy, and those are going to different requests. And you might not be able to see, but here's the IP address of the node that delivered the processed the result. As you can see, it's 10.0.0.5, and that one's 4, that one's 6, and so on and so forth. So behind HAProxy, the web farm is now processing all those requests. I could now go into the database and look to see the results. And once you get the kind of Docker bug, you end up running everything as a container. Now, a good friend of mine, Jessie at Docker, she literally, the only thing she installs on her desktop is Docker, and then Skype and Firefox and Chrome, and every single tool is run as a Docker container. Which means that when she gets a new machine, all she has to install is Docker, and she's got her whole environment. It really is quite crazy. There's a demo of it online. It's quite fun to watch. So I am going to run Aerospike's command line tool called AQL, and I'm going to just jump into the database. AQL minus host prod Aerospike 1. I did this earlier. What have I mistyped? Aerospike tools. All right. Here's a command I typed earlier. All right. So I can do select start from test summary, and there you go. So one of the collections or sets I'm maintaining is keeping the unique hits by application server. right? So we can use containers to not only run our application, we can use containers to run all of our tools to go look inside that. Okay, so going back to here, so we scaled the web tier, that's awesome. This is how we did it, and as I said, I'll post these slides, but we'll talk about some of these details. So now we want to scale the database tier. Right, so let's go do that. Now, as we talked about earlier, we've got two networks. What we need to ensure is that all the right pieces of the networks are hooked together. So I've deliberately left myself this to type in manually, so I can show you how badly I can type. So network, connect to the prod network, and I'm going to do prod Aerospike 1. I know I do. Okay. Alright, so I've now connected the service that's going to look to see whether there are other Aerospike containers running to the network, so it can see these containers are here. We'll see why that's important in a minute. So, how did we scale the database tier? Right, we did a Docker compose, oops, then we did a scale, and now instead of doing Aerospike, instead of doing web, I'm going to now scale Aerospike. I've got 3 containers started, and as we'll see down here, we now have 3 nodes running. Right, so using compose, it's a one-liner. I've now scaled it. I haven't changed any code yet. All I've done is start new containers, and I can actually go and carry on clicking on my web application, and I've got my scaled cluster behind that. And as one final piece of magic, if I can type properly, what I'm going to use is a tool that will show you the current cluster topology in Aerospike. So, So Aerospike, tools, use ADM. Oops. Of course, that. I always forget to do it. All right, and we'll let that run and gather the statistics of the cluster. So whilst that's doing that, so how do we do this piece of magic? Inside Docker, there is an event API. So as containers come and go, you can register to see those events. And so this is part of the state diagram of the state of a container. The full diagram's up on the Docker website. Our good friend Evan Hasler, he works at Docker, and he's built this framework called Interlock. And all Interlock does is it sits on the event framework looking for these events, and then you can build a plugin that subscribes to those events. So what we built is an Aerospike Interlock plugin that sits to see for these events of containers coming and going, and automatically reconfigures the cluster based on those containers appearing and disappearing. Docker itself, Docker networking doesn't support multicast networks. So the reason we have to do this piece of in seeing the events of containers coming and going is because we have to send a command to the cluster to tell a new node has appeared. On multicast networks, Aerospike just does this by default and automatically. There are plans for Docker to do multicast networks. Some of the vendors have got plugins that do that. Maybe at some point Docker will do it themselves. So if we go back to this command, you can see we now have 3 nodes in our Aerospike cluster. All right, so we have really scaled the cluster. We have really scaled the web tier, our database tier, without changing a line of code. And it was 2 commands at the terminal, which I mostly got right first time. So you can see how easy it is to not only scale this out in your development environment, you can scale it out in production environment as well. This is just an example of what the plugin looks like. It's a piece of Go code, but you can go and examine that afterwards. All right, questions on the demo before I move on? Have I blinded you with science? My friend over here.
If you wanted to, when you scaled to multiple containers on the same machine. If I wanted to scale, am I wrong in saying that?
You're wrong.
Okay, great.
So
But the database
here,
actually checked first, that's what he did first, right?
Yeah, because the deployment, that YAML
yeah,
file.
so each one of these boxes is a separate VM.
Okay.
It could be a separate node on EC2 or Azure or your own bare metal. So as you can see here, I've got 3 database containers running, and they're on separate hosts or Docker engines because I set that affinity rule that wouldn't allow them. So I could start a 4th one and it would slot it in here. As soon as I tried to start the 5th, based on that affinity rule, it wouldn't allow them, it would give me an error message saying you can't start. On the other hand, the web containers, I didn't give them that affinity rule, which is why there's multiple running on that same container, right? So as the ops team, you can actually specify what those rules and behaviors should be, what type of hardware should they be running on, and you can inject that and layer it on top of the other YAML files that have come through that development process. So you can isolate the developers from knowing what the physical topology is. They give you the base YAML file of how to run their application. You then inject that deployment topology, and you get now their image running in that environment.
That's awesome. Thanks a lot.
Question over here.
What about auto-scaling and demo integration?
So the question is, what about auto-scaling and failover of HAProxy? These are all important issues for you to think about, right? So I've got a single HAProxy here. What happens if that fails? That's not a good thing. You would then set up a HAProxy with its failover characteristics in other containers. So containers per se aren't going to do magic. They're simply going to give you a process environment to run in. So if you can take advantage of auto-scaling policies, either in Docker itself or the underlying technology or your monitoring or management tools, then you can launch those additional containers. It's kind of up to you and the tools that you want to use to achieve that.
It's very easy to scale up. Have you ever seen scaling down?
Scale down.
Because with the client load coming in continuously, that's your problem. In your case, you're a single client. So
all right,
you don't need it.
scale down is awesome. All right, let's scale down. All right, so Black Friday's gone. Nobody's voting for Coke or Pepsi anymore. So let's say.
So what about transient traffic that's coming? That's no way.
Sure. So you can scale containers up and down. So I've now said 3. So if we now go and look at the dashboard, there's only 3 running, right? So is this going to? Can you deal with that demand that's peaking up? Absolutely. You'll need to have some tools that are looking at that and figuring out another container needs to get deployed. Now, if you're using these techniques, when that container is deployed, it's already automatically going to get meshed in, and therefore your application can take a load. Docker is working on the automation of some of those activities, but that's a separate topic.
Scaling, actually, web tier scaling up and scaling down is being solved. What I'm worried about is the database.
Database, you can use the same mechanisms. Now, there is an implication of scaling down the database cluster, right? I'm on a 5-node cluster. Let's say I've got a replication factor of 2 or 3. That means there's multiple copies of that data. So if I take a node down, I have to ensure that other copies of that data reside on the 4 residing nodes. Right, so scaling up and down a database cluster is non-trivial, and it should be something that you kind of plan for, because if you're suddenly copying data around, your database is actually going to do a whole bunch of work as it's doing that. So the classic case is if you get to 90% utilization of your cluster, irregardless of whose database it is, and then suddenly add load to that cluster because you're copying data around, then you're going to be in trouble because you're going to hit that maximum utilization. So you kind of have to plan these things, and yes, there's tooling and automation around it, but you kind of, it's non-trivial, should we say.
If you scale up, there's some issue to get to move data around the world.
So the question is, as you scale up, you've got the same issue, absolutely. Now, some of the scaled up databases handle scale out really well. I think Aerospike is one that deals with this particularly well because it's a hash-based partitioning scheme. Databases that are range-based partition have an ordinate impact on particular nodes within that cluster. So with a hash-based, you're spreading the load across the available nodes in order to construct a new node. On range-based, you're typically going after one or two nodes really hard to go and suck the data out. So there are pros and cons here to kind of work through. It's going to be different per database. I think some just work better for this than others.
So it wasn't obvious what kind of a service discovery mechanism was used by the web tier to discover the Aerospike nodes as they were added.
Great question. So how did we do service discovery? So who's used HAProxy here? A couple of you. Okay, so HAProxy is a load balancer. What you have to do is you have to give it a configuration message to say there is a new web server, app server here. Right, so the piece of automation was Interlock. Interlock saw that this container started and it automatically rebuilt the HAProxy reconfigured HAProxy so it knew that node was there and now it could add it to its list of round robining.
I asked specifically about the Aerospike nodes.
Yes, and for Aerospike we did the same, with the Interlock plugin we did the same thing.
So it's basically a plugin for Docker.
Yes. Now, Docker has recently got a service discovery API. We're looking to integrate with that so we can do it natively through that mechanism too.
So are you saying that the client needs to know about all the nodes? Or who is it deciding which node to go to? Like if it's sharded?
Great question. So the question is, how does the client know where to go? So inbuilt into the Aerospike client is essentially when you connect, you need to give it a seed list. All it has to do is connect to any one of those and then discover the rest of the topology. Now, how does it know where the data should go? As I said earlier, we've got a write-MD 160 hash, and the first 12 bits of that hash essentially govern the partition and the physical node. So the client can redirect that get or the put to the right node in the cluster by just looking at the hash. Because inbuilt in the client, it's got a map of those partitions to the physical hosts. And that's been constantly updated as that topology is changing. All right. So, some considerations. Where should you store your data? Should you store your data for a database inside the container? Anybody vote for that? I'll vote for that. For dev test, it's awesome, right? Because as soon as the container goes, all the data goes. Do you want to keep your development data? Well, sometimes, but often you just want to throw it away. So typically, on the left-hand side, you'd use in pre-prod or dev. The right-hand side is much more typical for production because you're either storing the data outside the container on the host, on your EC2 host or your bare metal host, or you're storing it in some network device. In EC2, this would be EBS. Right? Why do you want to do that? Because if the container stops and restarts, you can attach this external storage. Do you choose this or this? It comes down to your operational preferences. Some people want to do it here, like you put the data in EBS volume because they like EBS snapshots for backup. Some people want to put it on the host because they're using some host technique. Again, with Aerospike, we're distributing the data across many nodes, so you've got inbuilt reliability and availability. So if you lose a node, there's more than one copy of the node. More recently, Docker introduced data containers. We've still got these in the lab trying to figure out are they good or not. But essentially, in a data container, you can attach a data container to a regular container, and the data container's got special rules about destruction. You can't simply just close the container down because you lose all the data. So there's a whole bunch of mechanisms to stop you shutting down the container if it's a data container. But obviously you've got a network hop here in order to get to storage. So we've still got that in the lab, still doing performance and reliability analysis to see whether that actually makes sense. So that's work in progress. And here's a summary, which is what do containers give you? They give you a simple way to get from dev to production and insert the behavior that you need. There are people running containers and databases in production. They exist today, we have customers doing it. It's increasingly looking like more people will do that. You have to plan for it, it's not going to happen automatically. And you need the right database infrastructure in order to support that. And that's all I've got.
All right, guys. Anyone here not put a card in who wants to win a $100 Amazon gift card? You didn't, so pass this around.
I don't have anything.
Business card. No, seriously, no. Here, wait. Oops, sorry. I don't know. Find something to write on. Anyone else not? We're gonna do the raffle in a minute. All right. While that's going around, let's take some Q&A questions. Hands? Yes.
You showed an example with a counter. How does it work when there is a failover scenario? Like when you are saying treat me this counter and server fails, do you retry if it's still consistent?
Yeah, so a write in Aerospike is a synchronous write across all of those replicas. So if I've got a replication factor of 3, all 3 need to respond yes to that write before it's acknowledged to the client. So we work differently to a number of other.
So is this client who does all 3 calls?
No, the write goes to the primary, the primary node for that record. That node coordinates with the other nodes for the replication factor.
This node fails. I don't know if write succeeded or not. What should I do?
Right. So on your client. You'll get an error saying either a network timeout or the operation failed. It really depends on the scenario. Then it's going to be down to your application logic of do you retry that or do you do a compensation for failure. There are a number of patterns you need to follow in order to decide what to do next. Aerospike's really no different to a number of databases out there. We unfortunately leave it for you to figure out what's the best thing to do. Okay. Yes.
Aren't there some reviews that sort of say there's some potential for data loss and that Aerospike might not be fast for like mutable data? It might be good for like foods, but mutable data, there's some data loss because of what low network latency or something like that? Is that
yeah, so the question is, can Aerospike loosen data? Absolutely. If people are aware of Carl Kinsbury's work on the Jepson tests, Carl works for Stripe, which is a payment processor, and he's been putting many SQL and NoSQL databases through Jepson, and almost all have fared very badly. Some have failed much better, but they have still failed those tests. So the Jepson tests are all about consistency, reliability, and repeatability. His work is extraordinary. If you've read any of his articles, they're very, very informative. We're in the process of working with Carl and getting this Jepson test to pass. So there are some circumstances in network delays where we have some work to do, frankly. But so does all the database vendors. So I feel bad, but I kind of feel that we as an industry have got all room for improvement.
Can it have in memory database?
So the question is, can you run Aerospike in memory? Absolutely. You can configure it so it's pure in memory, so it works like a cache, or you can do a memory plus app with an SSD, so you've got persistence. So it's up to you. Yeah.
Have you ever encountered any situation that Dockerizing, like any application that you
So the question is, are there any applications out there that are going to be Dockerized? Absolutely. Many of the vendors are pushing out Dockerized images of their products. Zookeeper and that whole ecosystem, I don't know per se. Sorry?
If they don't want to use a container, how do you solve this situation?
So, I mean, if public images don't exist for those components, it's easy enough to create one for yourself. And what I often see is big corporations aren't using the public images. They may use the public image as the base, but they're keeping a repository on their side of the firewall with their specific things, i.e. they've got their blessed versions of those images. And so it's easy enough to create a Docker image, either because one doesn't exist or you believe that you have to change the set of dependencies to meet your needs. Yeah.
How do you support transactions?
How does Aerospike support transactions? So Aerospike is atomic per statement. It's not atomic, but we don't support multi-statement transactions. Which is a fairly common pattern for most NoSQL databases. The rationale being, in order to support multi-statement transactions, you have to essentially support two-phase commit across all 30 nodes. Two-phase commit introduces latency, amongst many other complications. And Aerospike is essentially a high-performance key value store. And the criteria we've got is to not break that promise.
Time for one last question, yes.
So what kind of other containers did you also research before you basically settled recommending Docker?
The question is, why choose Docker?
Yeah.
You know, it's one of these kind of popularity contests, which, you know, at high school you probably all saw. Just some things more popular than other things. So Docker is the front runner. The great thing about Docker is that it's an open initiative, it's an open standard. If something better comes along, we're not particularly wedded to Docker. You see it as a popular way of distributing and building these types of infrastructure. If something better come along, if Rocket actually proves to be more reliable and more consistent and better uptime, we as a vendor, we honestly don't care.
Has everyone had a chance to put in your card for the Amazon gift card? Yes, yes? Okay. So before we give this away, let me just first give a great big round of applause to Alvin and Richard. We are going to raffle off this card, and then Alvin will be here for one-on-one questions. So if you want to come up and speak to him right after the raffle, feel free to do that. Can I ask you to mix it up?
And it's actually it's one prize of $100, but actually 2 cards because I could only find $50 cards.
Okay, reach in and grab one out without looking. Read it.
Oh, okay. Brian Jenkins.
Brian Jenkins?
Is he here?
It used to be Hudson.
Too bad. All right, reach in and grab another one.
You've got to be here to win it.
Absolutely.
HOA, and then it's
That's it.
NGU.
Thank you all for coming.